Welcome! In this video, we're going to explore the IFS function in Excel. This function offers a modern way to write nested if statements. The IFS function simplifies complex nested if statements, making your formulas easier to understand and manage. Let's start by understanding the problem with traditional nested if statements. Take a look at this example. Equals if, open parenthesis, A1 is greater than or equal to 90, A, if, open parenthesis, A1 is greater than or equal to 80, B, if, open parenthesis, A1 is greater than or equal to 70, C, if, open parenthesis, A1 is greater than or equal to 60, D, F, close parenthesis, close parenthesis, close parenthesis. As you can see, nested IFs can quickly become hard to read and understand, and they are difficult to maintain and modify. Now let's meet the IFS function. The syntax is as follows: equals IFS, open parenthesis, condition 1, value 1, condition 2, value 2, and so on, close parenthesis. The IFS function checks multiple conditions and returns the first matching result, making your formulas cleaner and more readable. Here's a comparison of the nested if and IFS functions for the same logic. The nested if is shown here. Equals if, open parenthesis, A1 is greater than or equal to 90, A, if, open parenthesis, A1 is greater than or equal to 80, B, if, open parenthesis, A1 is greater than or equal to 70, C, if, open parenthesis, A1 is greater than or equal to 60, D, F, close parenthesis, close parenthesis, close parenthesis. The IFS function provides a cleaner approach. Equals IFS, open parenthesis, A1 is greater than or equal to 90, A1 is greater than or equal to 80, B, A1 is greater than or equal to 70, C, A1 is greater than or equal to 60, D, true, F, close parenthesis. Both formulas achieve the same result, but the IFS function is more straightforward and easier to read. Let's break down how the IFS function works step by step. Step 1, it evaluates the first condition. Step 2, if the condition is true, it returns the corresponding value. Step 3, if the condition is false, it moves to the next condition. Step 4, it stops at the first true condition found and returns its value. This makes the function efficient by avoiding unnecessary calculations. Let's consider a practical example. Suppose you want to rate sales performance based on revenue. You can use the IFS function like this. Equals IFS, open parenthesis, B2 is greater than or equal to 100,000, excellent, B2 is greater than or equal to 75,000, good, B2 is greater than or equal to 50,000, average, B2 is greater than or equal to 25,000, below average, true, poor, close parenthesis. This formula checks the sales revenue in cell B2 and assigns a performance rating accordingly. Now let's discuss the key benefits of using the IFS function. First, it is readable. The IFS function offers a clean and linear structure that is easy to follow. Second, it is maintainable. It is simple to modify and update conditions as needed. Third, it is efficient. The IFS function stops at the first true condition found, which saves processing time. Here are some best practices to keep in mind when using the IFS function. First, order conditions from the most specific to the least specific. Second, always include true as the final condition for a default value to ensure that you always return some value. Third, use the IFS function when you have 3 or more conditions to evaluate, as it offers the most advantages over nested if statements in such cases. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.